Welcome, viewers. Okay, so we are going to review the first quadrant of the unit circle, and then I'm going to take you to the actual unit circle, and we're going to see how that applies, because we don't have to memorize the whole thing. If we understand the first quadrant, we can just reflect it using negatives and positives depending on what quadrant you're in, and then it's much easier to learn it. There's no need to memorize the whole thing. So we're going to start with first quadrant. So the reason why we went over special right triangles recently is because the unit circle really revolves around, is created around special right triangles. So if I look at this, if I create a triangle right here, okay, right triangle. This is a 30, 60, 90 triangle, which means, and the length of, for this circle, the length of the hypotenuse, or the radius of the circle is always, of the unit circle is always 1. Okay, so we have that length, 1. In the special right triangle, that is the length of the hypotenuse. And we know the relationships in the special right triangles. The relationship between the hypotenuse and, this is the short side right here. We know that's the short side because it's across from the 30-degree angle. Okay, so we've got to get the short side first, and then we can get the long side. We have the hypotenuse. The hypotenuse is twice as big as the short side. So the short side is 1/2. And then, all right, is everybody with me? So we did review special right triangles. And then the relationship between the short side and the long side is times the square root of 3. So 1/2 times the square root of 3 looks like this. 1/2 times root 3, that's like root 3 over 1. That's going to give you root 3 over 2. Root 3 over 2. Now this coordinate right here, okay, if we're just graphing it, for example, the x coordinate goes first. So the x coordinate is root 3 over 2, and the y coordinate is 1/2. Okay, so now I am going to go to that's what I call the short triangle. This is the taller triangle. I'm going to skip the middle one because that's the easiest. The taller triangle, this angle is 60 degrees, okay, which makes this angle 30, which makes this side the short side. Can everybody see this triangle? It's right here.
Yes.
Okay, so this is the short side and that's the long side. Using the same hypotenuse as 1, the short side is going to be 1/2, and then the long side will be root 3 over 2. So it's actually flipped from this one here. So for this point here, it's the same values, but the x coordinate is 1/2, and the y coordinate is root 3 over 2. And the sign from SOHCAHTOA, do you guys remember SOHCAHTOA?
Yes.
SOHCAHTOA. Sine is the opposite side over the hypotenuse. So the sine of 30 degrees is the opposite over the hypotenuse. So the sine of 30 degrees is the y value, 1/2. So if I'm trying to find the sine of 30 degrees, we're going to use the y coordinate. We're going to try to find the cosine of whatever value. Cosine is the adjacent over the hypotenuse. So that would be the x coordinate over the hypotenuse. So the y value is sine, and the x value is cosine, okay, for all these. All right, let's do the middle triangle now. So now you have this recording. You can watch it, like, you know, on Friday night with all your friends. Actually, let's make that Saturday night, because Friday night you're going to be going to the game. We're playing Quadrant, and it's going to be amazing. Everyone needs to go. We should talk about the setup of this game. We can't do this right now because I'm recording. I would much rather talk about that than do this, but for some reason they don't pay me to talk about high school football. Okay, so this triangle right here is the other special right triangle, the 45, 45, 90 triangle, which is nice because the legs are the same length, which means these values are going to be the same. And the relationship between the hypotenuse and the legs is we divide by the square root of 2. Now, if we do 1 divided by the square root of 2, we can't just leave it that way. It's not rationalized. So we rationalize the denominator. You don't have to go through all this. But you get root 2 over 2. That's where those numbers come from. So the long leg and the short leg, they're both root 2 over 2. And then this ordered pair right here, the x coordinate is 1, the y coordinate is 0, and up here, the x coordinate is 0, and the y coordinate is 1. How are we doing? If you know all of those values from quadrant 1, we can just basically reflect them, and depending on, like, the first quadrant is the x coordinate is positive, the y coordinate is positive. In the second quadrant, x is negative, y is positive, and so on. We're just going to change the values depending on the signs of the quadrant that we're in. We're not going to memorize the whole thing. All right, so now, really the hard part is counting for this unit circle. Let's start with the angles. All right, so notice, in the first quadrant, we have 30 degrees, and then we have 15, right, from 30 to 45, and then another 15 from 45 to 60, and then another 30, okay? It's like that all the way around. So, erase that. I'm just gonna fill in all the degrees first. 60, 70, 80, 90. Okay, this one is gonna be 120, because we're adding 30. Now we have to add 15. So that's 135, and then another 15 is 150, and then halfway around is 180, which we already know. How are we doing? Okay, so another 30 degrees, 210. Another 15 degrees, 225. Another 15 degrees, 240, and then another 30, 270. We kind of already know the 270. I love this last quadrant here because it's pretty easy to add 30 to 270. That's just going to be 300. And then 315, and then 330, and then this is 0 or 360. And that's how you get all the values for the degrees on the unit circle. And you'll get more comfortable with them as soon as you see them more and more often. Okay, so now let's go to pi. Let's go to the radians. If you were to convert all of these using the conversion that we learned last time, where you do, if you take the degrees and you multiply by pi over 180, you'll get these values, okay? But we know that this is 0 or 2 pi. All the way around is 2 pi. Halfway around is pi, which makes, if from 0 to pi, that makes this pi over 2. 90 degrees is pi over 2. So 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2, which is just 2 pi. How are we doing with counting in halves? Okay. Now, we don't have to do these numbers in any particular order, but I guess I'll start with sixths. Let's do that. If I take this half circle, and I break it up into sixths, okay? We have, I'm gonna use a different color. I'll use black. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, which 3 pi over 6 is equal to pi over 2 when you simplify it. I'm just breaking this half circle into 6. 4, 5, 6. Now what happens is some of these need to be simplified. So pi over 6 is already, 1 pi over 6 is already simplified. That's just pi over 6. But the next one, 2 pi over 6, can be simplified. 2 pi over 6 is simplified to pi over 3. Three pi over 6 we already have simplified as pi over 2. 4 pi over 6 we have to simplify. What would that be? 5 pi over 6 can't be simplified. We just got to write 5 pi over 6. 6 pi over 6 already simplified. 7 pi over 6 can't be simplified. 8 pi over 6 can be simplified. What would that be? So where am I at? 7 pi over 6, 8 pi over 6, 9 pi over 6, already simplified. 10 pi over 6, what would that be simplified to? And then 11 pi over 6. So you'll notice all of the short angles have a denominator of 6. See how there's pi over 6 and 5 pi over 6, and then in these quadrants we've got 11 pi over 6 and 7 pi over 6. And all the tall angles have denominators of a 3. So that's 1 pi over 2, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and then 6 pi over 3 would be the same thing as pi over 2. I mean, if you have trouble with fractions, this is, it's not easy, okay? So we've got all those. Now we can go to the fourths, and I'll do that in maybe purple. So if we're counting in fourths, we've got 1/4, 2/4, 2/4, 3/4, and then 4/4. Those are terrible lines. Okay. So pi over 4 is just the first one. 2 pi over 4, which has already been simplified to pi over 2. 3 pi over 4. 4 pi over 4 already been simplified. 5 pi over 4. 6 pi over 4 already been simplified. 7 pi over 4, last one. And when you get more comfortable with this, you're just going to start knowing them. But really, you only have to know, you have to have an idea. You have to know how to count those. But now these values, we are just going to reflect. So for example, pi over 6, this is the same triangle, special right triangle, right here. And we know the x distance is positive this direction, and it's negative this direction, but it's the same distance. So that ordered pair is going to be the same as this one. It's just the x coordinate is going to be negative, but the y coordinate will still be positive. So we're just going to use these values over here. We'll do the same in the other quadrants with the different signs. So we've got negative root 3 over 2, and then positive 1/2. Negative root 2 over 2, positive root 2 over 2. This is messy. And then negative 1/2, and then root 3 over 2. So in the second quadrant, the x value is negative and the y value is positive. That is so messy, sorry. Maybe I should use a smaller pen. Do that. Now we're going to go ahead and reflect them in to the other quadrants. Okay, so I haven't put this in. This point is x coordinate is 1, y coordinate is 0. This one is x coordinate is -1. We're going to the left, -1, 0. And we might as well just do 3 pi over 2 as well. If that coordinate is x coordinate is 0, y coordinate is 1, then down here this is 0, -1. Are we good? Okay. So now in the third quadrant, the x coordinate is negative as well as the y coordinate. So we're going to use all the same values as our other quadrants, but both our x and our y will be negative. So, short angle. We've got negative root 3 over 2, 1/2, negative root 2 over 2, negative root 2 over 2. I cannot wait to get my Promethean board. My handwriting will be so much better. Writing on this like laptop is just, I'm not a fan.
Does it have like a tablet mode?
I'm writing on Active Inspire right now. You can use OneNote as well. It's just not any better for, we've tried everything. This is like the best it's gonna get. It's hopefully temporary. Okay, so now the last quadrant, the x coordinate is positive. So that's gonna be root 3 over 2. However, the y coordinate is negative. So this is root 2 over 2, and then negative root 2 over 2. And then this is positive 1/2, and then negative root 3 over 2. I don't know why they thought that we could teach on a TV. I don't even know. It might be okay for some subjects, just not math. That's it. I do have to teach you tangent, and tangent is always the most difficult. So this is very messy. I'm going to take you back to quadrant 1 to do tangent. Does everyone have this written down? Okay, let me erase some of this stuff so I have some space. Okay, as we know, the tangent in SOHCAHTOA is the opposite side over the adjacent side. So the opposite side is the y coordinate, and the adjacent side is the x coordinate. So technically, tangent is y over x, okay? So if I need to find the tangent of 30 degrees, it's going to be opposite over adjacent, or y over x, which is 1/2 over root 3 over 2. You don't have to do this every time because you're going to memorize it. 1/2 divided by root 3 over 2. We never divide by fractions, we always multiply by the reciprocal. So we keep change flip. This is why you don't have to write this all down. The 2's are going to cancel, and you'll end up with 1 over root 3, which we don't leave that way. 1 over root 3. We have to rationalize, and we get root 3 over 3. So the tangent of 30 degrees is root 3 over 3. I'm just going to write it over here. Now what's great about the tangent of 45 degrees is that when you put y over x, those values are the same. So it's either going to be 1 or -1 depending on which quadrant you're in. In this quadrant, y and x are both positive, so it's just root 2 over 2 over root 2 over 2, which is just 1. Then, the other way, when you divide root 3 over 2 by 1/2, root 3 over 2 divided by 1/2. Keep change flip, root 3 over 2 times 2 over 1. The 2's cancel, we end up with root 3. My suggestion to you, and I will have to say this many, many times because people will not do it, memorize the tangent of 30 degrees is root 3 over 3. Tangent of 45 is 1, tangent of 60 is root 3. Just memorize it, because you don't want to have to do this division every single time you need to do a problem. And you're going to have to do cotangent too. You have to flip it. It's going to be a pain. Just memorize it. The way I like to remember it is, the 1 is easy. It's these two we get confused. Root 3 over 3 is smaller than root 3 because this value, root 3, is like 1 point and some stuff, and we're dividing it by 3. So this is a smaller number than root 3. And so it goes with the shorter angle. So if you get confused, is it root 3? Is it root 3 over 3? The short angles are root 3 over 3. The tall angles are root 3. Okay? I think that is it. Yeah. All right, now we're ready for practice. And now we can analyze the setup of this game. Who wants to talk football? All right, we're out.